This web app, sorry, this not web app, this MATLAB app calls a Python script which does the actual idealization. So first thing we do is load a model. We've got many models available, but just for example, this one, that model's now loaded. We load a data file. Got various different data files, of course, that we can do. In fact, in this case, we'll do a bit of biological data that the model was never exposed to during training. So it's new, real data from an experiment. This will take a little while to come up. You'll notice I have this binarize button activated at yes. So that means despite the model is capable of predicting several different states, here we go, it's just going to predict open or closed. So there we go, it's predicted open or closed here. You can see that there are occasional second states here, but we're just sort of ignoring it. If we want to go in for a closer look, we've got various different tools to do this. They don't necessarily all match up and work properly, but here we go. So zoom in just more or less on the center. This is an interesting bit here around 0.035 seconds. So I will change the location to 0.032, and extending that up to say 0.038. 0.038. There we go, and you can see what it's made of that. There's a further option you can use sometimes for very noisy data. Let's see if this will work. Very noisy data where essentially we didn't find this when we published the original paper, so maybe we haven't got the best model here loaded into the user interface. But if you take this single state bit of data, sorry while it does this in the background. Does that in the background. Now it's loaded that. Of course it's zoomed in on a tiny little bit of data, so we'll swivel it around a bit, and that's what it's made of it. So I'm going to apply a dead time to that of a couple of data points because it's working too closely. It's still going to be imperfect, but there's some interesting stuff. There's some interesting stuff here around 4 seconds. So I'll zoom in around the 3.9 seconds up to say 4.2 seconds. 4.2 seconds, and you can see what it's made of, this very fast, choppy data in terms of idealization. Now, we found that this model does work okay if you take that off and use several different states, but I will confess we do seem to, subsequently to submitting the Deep Channel paper, we do seem to have picked up some bugs, and we're looking into those at the moment to find out why the idealization of the multi-state models are not working quite so well as they once did.